So we're going to practice something called compositions. To do a composition, we're going to put two functions together to make a new function. And the symbol for a composition is a round circle. It looks kind of like an O in my notation right here. So this looks like fog, but it's really F composed with G. And the order that we write this is important. F composed with G is different from G composed with F. So let's actually do our first example. All right, so notice F is first in the notation. So I'm going to go to the function that is F, this one right here. I'm going to put parentheses where its X is. So I'll have 2 times parentheses minus 3. So 2 times parentheses minus 3. Now, since G is second in the notation, G is going to plop into those parentheses. So I'll have 3x plus 4 in the parentheses. All right, now I just need to clean this up. Let me get rid of some space here. And then let's just distribute our 2 through the parentheses. So that's 6x plus 8. We still have our minus 3. And add like terms, we get 6x plus 5. That is F composed with G. We have a new function now, 6x plus 5. Now notice in this next one, we want to find F composed with G at 4. So it's still this function, but we want to plug a 4 in for our x. So let's just plug in 6 times 4 plus 5. So we'll have 6 times 4 plus 5. That's 24 plus 5, or a functional value of 29. All right, now we're going to go in the opposite direction. We want to find G composed with F of x. Notice again, order matters. Let's put the G first. So G, we're going to go to G, which is this function right here, and put parentheses in for its x. So we're going to have 3 parentheses plus 4. And now F is second in the notation. F will drop into those parentheses. So 2x minus 3 will drop in here. All right, and I'll just get rid of some of that extra space. And let's clean this up. All right, so let's distribute our 3 through the parentheses. We'll get 6x minus 9 plus 4. Add like terms, and that's 6x minus 5. And notice that these two functions, F composed with G, are different from one another. All right, so now let's take the function we just got, G composed with F, and let's put a 4 in for x. So we'll have 6 times 4 minus 5, which is 24 minus 5, or a functional value of 19. Okay, so now let's do a little more complicated example. We're going to take it through. First, F composed with G. So F is first. Let's put parentheses into its x's, and it has 2 x's, so we're going to put it in both places. So we'll have parentheses squared, and then we're going to have plus 3 times parentheses, minus 5. So I have replaced the x's with parentheses. Now G is second in the notation, so let's plop G into both of these parentheses. So we'll have 2x minus 4 and 2x minus 4. And I'll get rid of some of this extra space in here from typing. All right, now we need to clean that up. So to clean that up, let's first remember that 2x minus 4 squared really means 2x minus 4 times 2x minus 4. And we'll go ahead and FOIL that out in a minute. But let's go ahead and distribute the 3. That's 6x minus 12. And we still have the minus 5. Now, let's FOIL out the 2x minus 4. 2x times 2x is 4x squared. 2x times negative 4 is negative 8x. Negative 4 times 2x is negative 8x. And negative 4 times negative 4 is positive 16. And then I'll just retype all that other stuff. And then let's add all of our like terms, and we'll have this new function. So 4x squared And let's add all of our x terms. Let's see, we have negative 8, and negative 8 is negative 16x, and the 6x makes it negative 10x. And then 16 and negative 12 will be 4, minus the 5 will be negative 1. So there's our new function. Let's notice in our next one, we want to find the functional value of f composed with g at 1. So we want to replace our x's with a 1. So we'll have 4 times 1 squared minus 10 times 1, whoops, minus 1. And really that's going to give us 4 minus 10 minus 1. Let's see, negative 6 minus 1, negative 7. All right, now let's go the other direction. Let's find g composed with f. G composed with f, g is first in the notation. So we want to put 2 times parentheses minus 4. And we're going to see that this one is easier than the last one. And now let's plop f, the second one in the notation, into those parentheses. So all of this is going to plop into here. That's x squared plus 3x minus 5. And I'll just get rid of some of the extra space. And now let's clean this up. And really, we need to just distribute the 2 through the parentheses. So 2x squared plus 6x minus 10 minus 4. And let's add the 2 like terms, just the minus 10 and the minus 4. So we'll have 2x squared plus 6x. And minus 10 and minus 4 will give us minus 14. And notice how different that answer is for g composed with f than f composed with g was. So they're quite different. Now, we're going to take our g composed with f function and put a 2 in. So let's put a 2 into the answer that we got into our x's. So we'll have 2 times 2 squared plus 6, oops, plus 6 times 2 minus 14. So really this is 2 times 4 plus 12 minus 14, or 8 plus 12 minus 14. And 8 and 12 is 20, minus 14 is 6.